I'm Anil Kumar. As a part of practicing for the test, here are 4 questions on limits. We need to evaluate following limits. The first one which we'll do is limit when x approaches 5 for square root of 25 minus x square, and then we'll take up limit when x approaches 1 for ninth root of x minus 1 divided by cube root of x minus 1, and then we'll take one which is kind of here where we need to do rationalization to find the limit as x approaches 0, and the last one includes absolute function where we may have to write as a piecewise function, correct? So these are 4 very different examples, and they will help you to understand how to do most of the examples on limits. You can always pause the video, copy these questions, answer them, and then look into my suggestions. So let's see the first one, which is limit when x approaches 5 for square root of 25 minus x squared. Now to understand this, let us sketch this function, right? So if you sketch this function, what do you get? You'll get something like a semicircle, right? This is equation of a semicircle. You'll get a semicircle like this, where the radius is 5 units, correct? 5 units, plus and minus. Okay. So as you can see from the graph itself, what is the limit when x approaches 5 from the left side for square root of 25 minus x squared? Now if you are approaching from the left side, you are approaching the value 0, right? So at this limit is indeed 0. However, what is the limit when x approaches 5 from the right side for 25 minus x squared? Now when you approach from the right side, it does not exist, correct? Since that limit does not exist, right, and we know that limit for x approaching 5 from the left side for square root of 25 minus x squared is not equal to the limit as x approaches 5 from the right side for square root of 25 minus x squared, we can say that the limit x approaches 5 for square root of 25 minus x squared does not exist, correct? Now clearly the domain of this function is within plus minus 5. So the alternate method could be find the domain. Domain for square root of 25 minus x squared is that x is between minus 5 and plus 5, correct? So you cannot approach from the right side. That is the reason that this limit does not exist, correct? Now let's take the next example, which is to find the limit for ninth root of x minus 1 to cube root of x minus 1. Now here we could adopt different methods. So we could do substitution, for example. So let's do substitution. We could also directly do factoring, right? We can factor it also. Now what you notice here is that if I substitute 1 for x, now substitution doesn't mean substituting 1 for x, we'll do substitution by variable. But what I'm saying here is that if I write 1 here, then I get 1 minus 1 over 1 minus 1, so it is 0 over 0. That means indeterminate form, correct? So in such cases, we have different methods. So the methods normally adopted are factoring, or we could do rationalization, or we will do variable substitution. In this particular example, all the three methods can be used. Okay. Now, let me take up variable substitution here. Now, ninth root of x could be substituted as, let's sub ninth root of x as, let's say, variable u. Okay. Then, what is cube root of x? Cube root of x will be u cube. That's first thing. Now, if x approaches 1, then u approaches what? If x approaches 1, ninth root of 1 will also be 1. So u approaches 1. And therefore, we can write limit ninth root of x minus 1 over cube root of x minus 1 as x approaches 1 as equal to, we'll write this as limit u approaches 1, and ninth root is u, so we say u minus 1 over, that becomes u cube minus 1. Do you see that? Now at this stage, we could factor u cube minus 1. Now I hope you remember a cube minus b cube is a minus b times a square plus ab plus b square. So we can factor the denominator. So we get limit u approaches 1, numerator is u minus 1, and the denominator is u minus 1 times u square plus u plus 1, correct? Now u minus 1 cancel, so what we get here as limit u approaches 1 for 1 over u square plus u plus 1. Now in this case u is 1, so I get 1 over 1 plus 1 plus 1, which is 1 over 3. So the limit of this function as x approaches 1 is 1 over 3. So let's take the next example, which has absolute functions in it. Now whenever you are working with absolute functions, it should be written as a piecewise function. So absolute value of x minus 1 is equal to x minus 1 if x is greater than or equal to 1. And it is negative of this, that is minus x plus 1 when x is less than 1. And therefore, all the absolute functions should be solved as a piecewise functions, and here the two pieces will be considered as when x is less than 1 and when x is greater than or equal to 1, since that equation is going to be different, right? So in the first case, when x is less than 1, we'll take minus x plus 1 for absolute x minus 1. So our question becomes limit x approaches 1 for x squared. Now absolute value of x minus 1 when x is less than 1 is minus x plus 1. So we'll write this as minus x plus 1. Then we have minus 1 here. Denominator will also be minus x plus 1. For the right side, the question will change as this. Since for x greater than or equal to 1, absolute value is the positive value. So we get x squared plus x minus 1 over x minus 1. Do you see? Now we'll solve each. Now this is from the left side and this is from the right side. So when we say x is greater than or equal to 1, that means we are approaching from the right side. And this is from left side. Right? So 1 minus, correct? So in this case, if you simplify, 1 minus 1 is 0. So we get limit x approaches 1 from the left side as x squared minus x over, we have minus x we could take minus common, write this as x minus 1, correct? Now the numerator, also we can take x common, so we get limit x approaches 1 from the left side, we can take x common, we get x minus 1, denominator is minus x minus 1. Now x minus 1 and x minus 1 cancel, and if I substitute 1, what do I get? If I substitute 1, I get minus 1 because of this minus, correct? On the right side, we get limit x approaches 1, but from the right side. Now here, it becomes x squared plus x minus 2 over x minus 1. Now, this can be factored, so we get limit x approaches 1 from the right side. So we could write this as x minus 1 times x plus 2 over x minus 1, right? Now, x minus 1 cancel, and that gives us the limit. When I substitute 1 here as 1 plus 2 makes it 3. Now you can clearly see that the limit when x approaches 1 from the left side for the given function, let's say f of x, is not equal to the limit when x approaches 1 from the right side for the same function, right? So therefore, it does not exist, right? So this limit does not exist. You see that? So for a piecewise function, we have to check the limit from both the sides and see whether it exists or not. If it is not same from both the sides, then it does not exist. Now here is the last example where we have square root. So whenever we have square root function, we have to rationalize and then find the limits. Now in this case, if I substitute 0 for x, what do I get? I get square root of 1 minus square root of 1 over, if I substitute 0, I get square root of 4 minus square root of 4, right? Which is equal to 0 over 0. So that's an indeterminate form. That means there is a factor of x in the numerator and also in the denominator. Now we could do rationalization to find the limit of such functions. Now since we have square roots in both, we'll have to rationalize both numerator and denominator. So let us see how to do it. So we have limit x approaches 0. The function is square root of x plus 1 minus square root of 2x plus 1 over square root of 3x plus 4 minus square root of 2x plus 4. To rationalize, we'll multiply and divide by the conjugate. So let's rationalize both numerator and denominator. So we'll multiply and divide by square root of x plus 1 plus square root of 2x plus 1 over square root of x plus 1 plus square root of 2x plus 1. That is rationalizing numerator. Now we'll rationalize denominator, which gives us square root of 3x plus 4 plus square root of 2x plus 4 over square root of 3x plus 4 plus square root of 2x plus 4, correct? Now, a minus b times a plus b is a square minus b square. So what we get here is, when you multiply these two terms, we get x plus 1 minus 2x plus 1. And we are left with this term, so let me write that as square root of 3x plus 4 plus square root of 2x plus 4, correct? Okay. Over, when we rationalize the denominator, that is multiply this with that, we get 3x plus 4 minus 2x plus 4, and we are left with square root of x plus 1 plus square root of 2x plus 1, correct? Now if you simplify this, what do you get? X minus 2x is minus x, so we get minus x in the numerator. Here 3x minus 2x is x, 4 minus 4 is 0, so you get x over x, correct? And here we have a term which is all this. So I'll rewrite this as square root of 3x plus 4 plus square root of 2x plus 4 over square root of x plus 1 plus square root of 2x plus 1. Correct? Now that cancels x and x, leaving minus 1. So we could write this as limit x approaches 0, so negative value, this is minus, and we have square root of 3x plus 4 plus square root of 2x plus 4 over square root of x plus 1 plus square root of 2x plus 1. Perfect. Now we can substitute 0 here. So we get square root of 4 plus square root of 4 over square root of 1 plus square root of 1, which is, so this is 2 plus 2, and here it is 1 plus 1. So we get 4 over 2, which is 2, right? So the limit of this function is indeed 2. Now in some cases, as we have seen here, we may have to rationalize both numerator and denominator. So I hope with this you got some review on the concepts learned in limits. Feel free to share your comments and your views. If you like and subscribe, that will be good for me. Thank you and all the best.